So the composition of functions again. Remember, you're plugging in the second one into the first one, and when it's g of g like this, you're plugging it into itself. Some people find it helpful to write it out again, so you can kind of see the two different functions. I mean, they're the same function, but so you can see it twice. So you can take this function and plug it in to itself. You're going to plug it in where the x is in the other equation. So you have x squared. So instead of x, you're putting the g function. And then I have plus 3x, and instead of x, I'm putting the g function again. So wherever the x is, I put an empty set of parentheses, and in those parentheses, then I can put the other function. So I got x squared plus 3x in that x, then I have x squared plus 3x over here. Then what I do is just simplify. Just do whatever you need to do to simplify the equation. So this one I need to square. So when I square, I need to multiply it by itself. So I take that times itself. And then distribute. So I have x squared times x squared. Give me x to the 4. X squared times 3x will be 3x to the third. And then I move on to the 3x. 3x times x squared will be another 3x to the third. 3x times 3x will be 9x squared. Okay, so that's the square part. Then I'm going to distribute the 3 over here, and I'm just going to drop it down right beside this. So I have plus 3x squared plus 9x. And once I got to here, now I'm combining all my like terms. So there's only 1x to the 4. I'm scanning through and looking at exponents. So I have x to the 4, then I have x to the third, and then x to the third. And that's all the x to the third, so I have plus 6x to the third. And I have x squared plus this x squared, so 9 plus 3 makes 12x squared. Then finally drop down the plus 9x. All right, so there I've got my simplified new function. And I want you to write out the name of the new function. So g of x. So that's how you would read the little circle. The little circle says of. So g of x. All right, so that's what we're doing for all of these. You're just plugging in the second function always into the first function. And so the g is going into the h. So I've got my g here plugging in to the variable for the h function. Okay, don't miss this negative in front of that x. So you got negative parentheses squared minus 2. Remember, wherever the variable is, that's where I put an empty set of parentheses. And then I can plug in what I need to plug in. So I plug in the g function in there, and then do what I need to do. So I need to square. Whenever you have a square with something to multiply in the front, your square is always done first. So I need to multiply this by itself, and then I can distribute whatever I need to distribute. So that negative can come down. Now, really, what I could do is distribute the negative into the first parentheses and then distribute into the second, but I think you guys will probably find it just as easier to just distribute this first. So negative 4x times negative 4x will be positive 16x squared. And then negative 4x times the 4 will be negative 16x. Another negative 16x, and then a positive 16. And then all of that, I need to drop this negative down and change all of the signs. Now, I could combine these guys first while I'm at it, so that's going to be a negative 32x. And then I can change all the signs. So I have negative 16x squared, positive 32x, and then a negative 16. Then you look back at your equation at the beginning and check, is there anything else I need to do with it? I took care of the square part. The only thing I haven't done anything with is this negative 2. There's nothing really to do. You just drop it down and combine like terms. So negative 16x squared, positive 32x. negative 18. And label it. So I have h of g